Okay, so we're happy today to present Maestro, which is a framework that offers rapid iteration for serverless orchestration. Now, some things that we're going to go ahead and cover today are serverless, what that is, and some patterns around working with serverless. Then we're going to get a little bit deeper into orchestration patterns of working in that area. And we're going to talk through that with an example so it's more easily understood. Get into AWS Step Functions, which is a solution in this area, and then some existing solutions utilizing that. And then we'll go ahead and present Maestro and what we're hoping to accomplish and what we accomplish with it. So serverless, when one hears that term, is actually a bit of an ambiguous term. Really, in the general sense, it has to do with offloading application code to the cloud. So the benefit of that is that a development team doesn't have to manage local servers, no maintaining, no provisioning. So that can be pretty time effective, but it's also cost effective. Now, there's actually a subset of serverless that is often conflated with the serverless itself, known as FaaS, or function as a service. Now, when we speak about serverless in this presentation, we're going to be focusing on that subset of FaaS, and it actually matches well with how many developers understand serverless. We see in the graphic here, one poll represents that some 60% of developers, when they heard the term serverless, equated it with FaaS. Now, FaaS really has to do with, again, with application code offloaded to the cloud, but here we're talking about really small applications. Ideally, these applications have a single responsibility. Now, the particular thing about FaaS is that these applications are on individual containers, which can be spun up in response to events. Those containers also spin down once the execution of that function or that application terminates. Now, so for this reason, FaaS really shines when it comes to scaling. See, a cloud provider can automatically spin up containers in response to events, spin them down, and only charge for the time that those functions were executing. Now, the most popular cloud provider at the moment is AWS, and their FaaS offering is AWS Lambda. Now, some facts about Lambda. And since we're talking about small applications, they have an execution time limit. Now, the limit is up to 15 minutes, but really defaults to 3 minutes. So ideally, it's a very small application indeed. Deployment size up to 250 megabytes, RAM 3000, and you can develop in some 7 languages. Now, there are some challenges when working with Lambda, one of which is state management. Since we're talking about containers that spin up and down, once an execution has ended, any state that existed during that function's execution disappears. So managing state for a larger application that utilizes various Lambda can be a challenge. Also, there's an issue of cold start, and what that's referring to is the spinning up phase of a container. A container hadn't already previously executed. It can take up to 500 seconds for that container to be provisioned. Now, AWS has offered something recently to be able to offer sub 100 millisecond provisionings. However, there's an additional cost to that, and it really looks like a model that doesn't tend to match a team using that model for all of their functions. Now, amongst others, what are you going to do if you have an execution limit? If you have a long-running process, that could be a challenge to reconcile. Further, what if something happens during execution and you need to peer into the system to see what happened? Since you're dealing with AWS, not a local system, you can only peer through the window that they give you to audit execution. So when we talk about Lambda, this is actually a very new field. Serverless in and of itself is new. And there's not really many best practices in how to develop or configure an application in this environment. So another challenge is configuration. Now, since there aren't really many best practices, what have been developed over time are some patterns for developing applications in serverless. Now, there's patterns that correspond to general categories. For example, availability. We've already discussed just a little bit about cold start, about execution limits, add to that failure, and you can see why there's many reasons that a function may not be available when it needs to do its part in an application. There's patterns to deal with that. Then, since we're talking about functions responding to events, there are some patterns for event management, managing the monitoring or scheduling or responding to a schedule of an event. Also, many services, including multiple lambdas, need to be able to communicate with each other to form a larger application. There's patterns for communication. And just like many applications, serverless or not, often a user needs to have some type of authentication or authorization. And so there's some patterns for dealing with user authorization. Now, Maestro focuses on one set of patterns, and that is the orchestration. Now, orchestration in a nutshell is the act of managing the workflow between multiple lambdas and, as required, other services. It's kind of vague, though, to talk about orchestration without actually thinking through a more concrete example. So imagine there's a sole developer in a startup who's given the task of building an application that allows employees to request the provisioning of a resource. That provisioning would have to be approved by a manager. Now, if the manager denies, then immediately the employee's notified. If the manager accepts, then of course the resource can be provisioned, access granted, later the employee is notified. Now, if the developer is rather savvy, they can perhaps think through this process and extract out some components. And those components would actually be represented by various lambda in a workflow. Now, what are some challenges along the way if one were to try and actually develop this workflow into a real application? Well, what about chaining the execution of these various components? What if a particular component needs a given input, or how do you process outputs? We've already discussed a bit state management. How do you resolve any issues regarding state management in this application? Execution type, well, it may be that one component executes and then synchronously the next one after the previous stop, but it also may be that the previous continues to execute whilst the workflow continues. That would introduce some asynchronicity. Well, how do you manage that in an application where the components are disparate? And then, of course, just simple branching logic. Well, where do you put it? How is that handled? Now, there's some challenges that come along with these various aspects of decisions to be made in orchestration. Communication challenges. Well, how do these services communicate? Where do you put orchestration logic? Reliability. Well, what if one of these components fails? How do we implement retry? How do we prevent failure? Also, as we mentioned, you can only peer into this system through the window AWS gives you, and AWS doesn't give you a unified log for monitoring execution of these services. So let's talk about some orchestration patterns that can be applied as we step through different portions of our workflow. Now, first off, it may be that the request that comes in is malformed, and that malformed request could lead to the manager failing once he receives it. That's less than ideal. So there's actually a validation that can be performed in what's called the Proxy Lambda pattern. Now, a Proxy Lambda, well, it sits in front of another component and invokes it conditionally. So in this case, the condition would be, well, no error is present. So in the case that the manager then receives a valid request only, what happens now that the manager executes, makes its decision? Well, how do we determine where next to go in our workflow? This branching, we could actually handle in another pattern, the orchestration lambda. Now, an orchestrator lambda is able to communicate with other services. Just like the proxy lambda, one thing to note is a lambda is capable of invoking another lambda. Now, in this case, let's consider that there is that 15-minute execution limit. Well, maybe the savvy developer has determined that there's only going to be a request in when a manager is available, or there's some other restrictions there. And suppose it's okay, this 15-minute limit is not going to be much of a problem to reconcile. That assumption made, well, what if we actually made the manager lambda the orchestrator lambda? And by putting business logic and orchestration logic side by side together, we've overloaded it or fattened it up. So we're affectionately calling this the fat manager. Next in our process, if our branching has been resolved and the manager accepts, well, let's provision. Yet provisioning may be a risky task to perform. That provisioning may fail. Now, ideally, the employee who initiated the request wouldn't have to wait some arbitrary amount of time and realize they never got a notification of denial or acceptance. Ideally, if this provisioning were to fail, something would be able to retry at least some determinate amount of times to see if we can provision again. Well, where could that logic go? We're already utilizing here the fat manager. Why don't we just fatten it out? We already got business logic and orchestration logic together, so why not just put it all in the fat manager? So we've got our fatter manager here handling that. However, we're reminded that we do have a 15-minute execution limit. Now, here, what if the provisioning were to succeed, but only after 15 minutes? The fat manager that was monitoring maybe would have spun down by that time. Or what if the provisioning takes a long time and then fails? See, we do see that there is potentially more risk there. Now, the developer knows the system relatively well and can say, perhaps, well, we can tolerate that risk. What are some other drawbacks? Well, we've really got a poor separation of concerns here because we've got this orchestration logic and the business logic together. And the consequence of that is every time we want to iterate on our workflow, we have to modify or at least consider the orchestration logic along with the business logic. So, you know, a developer may look at the fatter manager and say, perhaps we can refactor out the orchestration logic, just like we have the validator Proxy Lambda as an orchestration measure separate from the rest of the workflow. Well, if that's our intuition, why stop there? We can actually extract out an entire orchestration layer. That being the case, what would be the benefits? Well, we could return to this thin business logic as we see on the left, and then we have a pure orchestration logic. If we do that, this allows us to more quickly iterate because we can try different workflows without actually having to change the orchestration logic along with the business. Just change the business logic. That's really a lot easier. And it could be that we could find a service that could provide us some of the primitives that we would require in orchestration right out of the box: retry, branching, timeout. Now, before we get into a potential service that could give us some of that out of the box, let's consider a pattern that fits well for orchestration: the state machine. Now, a state machine, or state, when specifically talking about a workflow, represents a state at a given step in a workflow. Now, that state is dependent on inputs and conditionally would provide an output based on the execution. But really what the state machine as a whole is concerned with are the transitions between each step. As Ruan Udell, who's an AWS Premier Consulting Partner, stated when talking about state machines, he said, with them, you can describe your application as a mixture of your inputs, the states that your application can be in, and the transitions between those states. So the AWS offering for state machines is our AWS Step Functions. And to explain a little bit more about that, we're going to allow Zac to continue.
So let's talk about step functions. As Torrel explained, AWS Step Functions is essentially Amazon's implementation of a state machine, and it acts as the orchestration layer over your serverless resources, such as Lambdas. Now, in order to define a state machine with step functions, Amazon has created a language called Amazon States Language, or simply ASL. ASL is a declarative language which is written in JSON. So we have here a simple example of what a state machine would look like written in ASL. And there's also a nice visual that the AWS console creates for you. And on line 3, there is a required field called start at, and this specifies which state in the state machine will begin execution. You have to start somewhere. Then on line 4 is where we have our list of states. Now, often these states will represent a Lambda or some other service, but it doesn't have to. There are other types of states that exist to help orchestrate the workflow. For instance, there's a choice state, which enables branching logic. There is a wait state that will simply pause execution for some specified amount of time. There are others, but it's important to point out that Step Functions provides these different types of states to help facilitate the workflow you are wanting to accomplish. Now, in this simple example, we only have one state called Hello World, and it does reference a Lambda, which might just return a string of Hello World. And once the Lambda returns, the state machine must define what comes next. So on line 8, we see the end true, and that is signifying that there actually is nothing next in this case. We've arrived at the end of the state machine. So that's a simple example, but let's look at something a little more complex. We'll bring back the hypothetical example that Torrel discussed earlier of the manager deciding whether to approve a request for provisioning a resource. So here's that same workflow, but now implemented with step functions. This state machine is orchestrating several states, 4 of which are Lambdas. And let's look at a couple of these states a little more closely. There's the manager choice state, and it's of type choice, and it's actually not referencing any Lambdas. The previous state, manager, does reference a Lambda, and it's the output of that function that is then passed on as input to manager choice. We see here that if the manager's decision is accept, then execution continues to the provisioner. If deny, then a notification will be sent out. Now, if we look at the provisioner state, we see how one might implement retry logic. For states that reference Lambdas, such as this one, ASL has a field called retry built in that allows you to specify which types of errors to retry and how many seconds to wait in between, as well as a back-off rate and maximum number of attempts. Pretty handy to be able to put this orchestration concern here instead of writing some custom retry logic alongside business logic. So after a state machine has executed, using the AWS console, you're able to access an interactive execution event history where you can audit the inputs and outputs of the transitions between states all in one unified place. And also, the visual workflow will be color-coded to help you quickly determine what the outcome was of each transition, of each state transition within that execution. So a quick recap of some benefits. The core purpose of step functions is to provide orchestration to your infrastructure rather than maybe having to choreograph everything in some way. But it also has some really helpful built-in features. We discussed choice states for conditional branching and retry logic and unified logs and visual workflows that help with auditing executions. And there are others as well that we didn't touch on. But in addition to the benefits, there are also some challenges in working with step functions. One of the common complaints when working with step functions is that ASL is not very intuitive. It's a JSON-based language that's really optimized for machines rather than humans. And some state machines can get quite complex with dozens or maybe hundreds of states. Now, there are some tools out there that try to help provide a higher level of abstraction that compiles down to ASL, but these are not widely adopted as of yet, and there's still much unsettled debate regarding what the characteristics of these tools should be. So it seems that for now, the most effective way to alleviate the pain of working with ASL is to use templates to help you model the workflow you're trying to create. This at least provides a useful starting point for beginners and is a nice convenience for those who are already more familiar with the language. Another challenging area, and this isn't unique to step functions, is just working with the AWS console in order to deploy your infrastructure. Now, typically, since step functions is an orchestration layer, there are many services integrated with your state machine that need to be deployed right alongside it. And each of these, including the state machine, needs to have the correct region and account number associated with it and the right permissions configured. And each service has its own interface. So you're not doing this all in one place. And doing this all manually, especially in the AWS console, is tedious and error-prone process. So it's certainly an area that benefits from some automation. And indeed, there are several frameworks that aim to help the developer with these tasks pertaining to deployment. And I want to discuss some of these frameworks, but before I get into specific ones, I first want to point out a couple of tools AWS offers that these frameworks can leverage to help in automating deployment. The first is a service called AWS CloudFormation. And this is AWS's offering that allows you to basically create a configuration file that will contain all of the resources in your serverless infrastructure that you are wanting to deploy. It's known as infrastructure as code. So here, what a framework can do is to guide the developer through a process of creating framework-specific files that are then compiled down to CloudFormation, and then the whole stack is deployed at once. The other tool is the suite of AWS software development kits, or SDKs, which are APIs that allow the developer to work directly with individual resources from their language of choice. So basically, any framework in this space is going to be using one of these two tools. However, it seems the design philosophy of the framework will often inform which of these tools that the framework will employ. For instance, frameworks that aim to be a more general purpose tool will typically take the CloudFormation approach, whereas frameworks that have specific use cases in mind or are maybe geared toward a particular language will often opt for the SDK approach. So then let's discuss some of these frameworks, keeping in mind that we're really only interested in those that allow for the deployment of step functions. There are many frameworks out there that work great for their use case, but don't include step functions. So they're outside of the scope of this discussion. So the first one we'll look at is aptly called Serverless Framework, and it's the dominant player in this space. Serverless Framework is a more general purpose tool, so it takes the CloudFormation approach, and it does provide a plugin that allows you to include step functions as part of your deployment. So some of the good things about Serverless Framework is that it supports multiple runtimes. It automatically creates the permissions that are needed for the resources in your infrastructure, and it does provide some simple ASL templates. What's not so great is that these templates that are provided require the user to manually configure the resources which the state machine will be orchestrating. Also, the state machine definition must be written in YAML in order to accommodate serverless frameworks conventions, which isn't great because if you recall, ASL is written in JSON, so you now have to convert that to YAML. And finally, the general purpose functionality that serverless framework provides you does come at a cost, having 535 node modules as dependencies, which can really be bulky and unnecessary depending on your use case. The next framework we'll look at was created by AWS and is called the Serverless Application Model, or SAM. And SAM started providing support for step functions just a few months ago. It's similar to serverless framework in that it also is a more general purpose tool that takes the CloudFormation approach. And it also supports multiple runtimes and automatically generates the required permissions for your resources. But unlike serverless framework, you are actually able to deploy a working state machine from a template without having to make any manual configurations. It can all be done straight from the command line. However, there's only one template that is offered, and it has a relatively lengthy deployment time, taking a couple minutes. And there are several prompts that the user must respond to in the process. And once deployed, there doesn't seem to be a command that just as easily tears down. So that has to be done manually. So serverless framework and SAM are both more general purpose tools, and neither of them were designed with step functions in mind. They both later added support for step functions in the event that your app just happens to use them. So what about some more purpose-built frameworks? Well, there doesn't seem to be many that are designed with step functions in mind and that actually support step functions. But there is a framework built by Coinbase called Step. And Step actually allows the user to construct a state machine definition with a higher level language, namely Go. However, Coinbase seems to be one of the only users of their framework. In fact, they list the development status of the framework as beta. An additional drawback is that Step is not able to actually create a new state machine, but can only modify an existing one, which can be a hindrance to the developer who's wanting to quickly iterate on their workflow, but has to manually create a mock state machine first. Okay, so that's just a quick look at some of these frameworks and how they might be used to address some of the pain in working with step functions. But this pain really needs to be experienced firsthand without any of these frameworks in order to appreciate the problems that our framework, Maestro, was specifically designed to solve. So I'll let John walk you through some of the steps involved with deploying step functions with the AWS console, so you can experience some of that pain and then experience the ease of orchestrating your serverless workflows with Maestro. So I'll hand it to John.
So I'm going to take you guys through a walkthrough of what it looks like to work with the AWS console to create this example workflow. So if you take a look at this diagram that just appeared on the left, you'll notice that there are the 4 lambdas of the example workflow: the requester, the manager, the provisioner, and the access grantor. And in addition to that, there's also this whole orchestration layer, which encompasses all of those lambdas, an AWS Step Functions state machine. So let's go through all the steps required to set up a working application using only the AWS console. Here's a diagram that we will step through that represents the steps required to create the state machine. At the end here, where it says save definition, is when we're able to save and therefore execute the state machine. So first, a developer would have to navigate to the Step Functions web console. So they probably open up a new browser tab and go to console.aws.amazon.com. Next, they need to select the state machine and service specifically. Once they do that, they can navigate through the state machine specific page until they come across the select create state machine button. Once they go through here, they can start providing their ASL or Amazon States Language definition. Providing the ASL can take several minutes for a developer that is familiar with the language and knows exactly what they want to create. So for a developer who's not familiar with ASL, this step would take hours, which is something that all three of us experienced firsthand. So the developer, you finished giving that ASL definition, and now we can move on to the next step, which is just a few final tweaks of this definition, maybe changing the retry back-off rate. After that, we click the Save Definition button, and all is well, or so we think. It turns out that in the AWS console, you actually cannot create the state machine definition without first providing valid ARNs, or resource names, for each Lambda in the state machine. So we're going to take a look here at step number 6 a little bit closer and create all of these Lambdas first, so then we can go back over to the browser tab that is just hanging open with the state machine definition unsaved and provide those ARNs. So these are the steps required to create a single Lambda in the AWS console. This diagram represents all 5 of them. At the end is the copy/paste ARN box, which represents the act of copying the resource name of the Lambda and then providing it to the state machine definition that's in the other tab. So first, to create a Lambda, one must navigate to the Lambda console, similar to the state machine. They must then configure the Lambda, giving the name, configuring the runtime, and working out the permissions to give the Lambda. After that, the developer provides the Lambda's definition, which is a non-trivial task. After the Lambda has been defined, it can then be saved. And then once this Lambda is saved, we can retrieve that ARN, copy it, and then paste it and supply it to the state machine definition. It's important to realize here, though, that these are just the steps for creating one Lambda. We still have 3 more Lambdas that we still need to create and go through all these steps for, which is starting to become tedious. And if, say, you had 10 or even 20 Lambdas, things will quickly start to get out of hand. So once we finish creating all the Lambdas in our workflow, we can go back over to the state machine tab and finish providing that definition and finish it up. So here, the next step, once we paste those ARNs over, is to just do some last little configuration with the state machine with names, tags, logs, and permissions. Once those are provided, we can then save the definition, and now finally, the state machine is ready to be executed. So that's what it looks like to create all of these resources, but what does it look like to tear these down? Well, similar to creating these resources, we would first need to navigate to the specific service in the AWS console, do a little bit of clicking around, and then finally, this is where it starts to get a little bit different. We select the specific resource, so an individual Lambda or an individual state machine. We click on a drop-down menu, which will provide us the option to delete the Lambda or state machine. And then a confirmation modal will pop up, which we can then confirm the deletion of. And we can start to delete these resources one at a time. It is important to note here that it's not necessarily really hard to do this, but it's very tedious because we have to do it for each individual Lambda as well as a state machine. And just the tedium of clicking around in the console could cause the developer to kind of zone out and maybe make a wrong selection and delete the wrong Lambda, which is an irrecoverable mistake. So as I kind of highlighted before, there are a few problems with this approach of creating the resources in the console. First of all, it's very tedious. There's a lot of just pointing and clicking through the web interface. It's also rather unintuitive in the sense that the Lambdas have to be created first before the orchestration layer around them. This requires us to, or working in the console requires us to work with multiple interfaces. We have a tab open for the state machine, another one open for the Lambdas. And if we want to manually configure the permissions and roles, another tab open for that. And because of all of this, it is very slow to create and to delete these resources. Just for creation, there are 28 manual steps required to go through the console of, for example, pointing and clicking. And for deletion, there's 30 of them. Those two combined makes it very difficult to rapidly iterate upon our workflow. So this is actually where Maestro comes in. You've heard us all mention it, and I think it's time to take a good look at Maestro. So Maestro, what is it? Well, Maestro is a framework for building, deploying, and iterating with step functions on your local development machine. Maestro is open source. It runs on Node.js, and it's actually available as a published NPM package. It's quite easy to use. It only has a few simple commands in this toolbox, each of them having some inline help, and we've got good documentation for each of those commands. Maestro allows for fast deploys of whole workflows in about 3 seconds, and it can tear down those same workflows in about 2 seconds, allowing the developer to focus more on the business logic and rapidly iterate upon their application. So let's take a look at what it's like to deploy this same example workflow we've been talking about, but instead of using the console, this time using Maestro. So first, you create a new Maestro project just with that single command there. After that, you can optionally modify the project template that is given to you, which I will discuss a little bit more later. And then once you've made your final tweaks, you can just deploy it up to AWS with the Maestro deploy command. And at that point, it has been successfully deployed by Maestro and is able to be executed. Contrast this to the great time and tedium required to deploy manually using the AWS console. This is quite a stark difference. So let's just take one more look at Maestro actually being used now to really help drive home this point. So first we have a terminal here, and we can create a new Maestro project just with this command. It prompts us for a template to base our project off of, which we can do so. And if you see here that the format of a basic Maestro project looks like this with the Lambdas and the state machine definition. Once we tweak the definition, we can deploy it with a single command, and 3 seconds later, all of these resources are up here in the AWS console. We can take a look at it a little bit closer. You can see that's the same definition, and it's actually able to be executed as well. To tear down, it's also as simple as just a single command. 2 seconds later, it's torn down. And as you saw, all of those resources are no longer shown in the console. So let's take a little look at Maestro, kind of under the hood, looking at the core of it and the different commands that you can use. So Maestro uses templates to help you as a developer bootstrap your new projects really quickly. This is Maestro's solution to the tedious overhead of manually writing the ASL. You can create your own templates actually to reuse if you have a common workflow that you use a lot, and you can actually share it with other people as well. And it's worth mentioning, the Maestro provides 8 official templates out of the box. And if you see on the right, that's just an example of one of the template state machine definitions that Maestro provides. The Maestro new command is used to create a new Maestro project based off of a template. It allows the developer to really work locally just through their one interface in the terminal. So you no longer have to point and click through the AWS console. And because this allows you to create a new project based off of template, it reduces the overhead of manually creating your own ASL. The deploy command deploys a whole Maestro project really quickly. Again, just locally on your machine and just through the terminal. So just this one interface instead of the multiple web interfaces of the console. And it's really quick, so at about 3 seconds to deploy. Contrast this to AWS SAM, which is a framework that Zac discussed earlier, which it takes about 3 minutes to deploy. So Maestro is 60 times faster. And this really allows for the rapid iteration on your workflows. And last here, for the core part of Maestro, is the Maestro teardown command that deletes a project really quickly. It's like deploy, but in reverse order. And again, since it takes about 2 seconds to tear down a project, it allows for the rapid iteration because you can just tear down and deploy with a new change and just focus on working on your business logic. So we recognize that Maestro also has a few limitations. We don't pretend that Maestro is a one-size-fits-all solution. Right now, Maestro only supports a single language runtime in your deployed Lambdas, which is Node.js 12.x. Currently, the Maestro deployer and teardown only supports Lambdas and step functions. There's no native support for the other AWS services, so you will have to manage the deployment and tear down of those yourself. And Maestro isn't super configurable on a per project basis. So I'm just going to walk you through a few challenges that we, the Maestro team, encountered while building Maestro. The first category here is dealing with AWS IAM, or Identity and Access Management, which is the AWS service for managing roles, permissions, and policies. So to be able to use a role for a Lambda, and this role, to be able to use a newly created role, rather, for Lambda, you have to wait for it to fully propagate to all of AWS's data centers, which was an issue that we encountered. Another issue, or challenge rather, was determining what roles, permissions, and policies to give the state machine and to give each Lambda. And more generally, we ran into some challenges regarding reconciling asynchronicity and concurrency in order to have a rapidly, or just a really fast deployer that's also very stable. And last note here, Maestro is working in a niche ecosystem. There's not very many frameworks in this space that deal with step functions specifically. And because of this, we'd often had to blaze our own trail. So we're in continual development here at Maestro, and there's some items of future work for us to do. One that I'd like to point out is right now, we would like to support officially other AWS services like DynamoDB, SQS, EC2, ECS, and more, so that the deployer and also the undeployer of Maestro will be able to handle those natively. And just so you are all aware, this is the Maestro team, and thank you guys very much for coming. If you have any questions, we can start taking those now.
So it looks like we've got a question regarding how we dealt with any resource dependencies. during deployment with AWS. And, it's kind of a broad answer. I think, again, just to note that in order to deploy our example workflow, for example, really there's 3 services involved. It's the step functions, the Lambda, and IAM. So in order to deal with deploying to the step functions and Lambda services, both of those are dependent on IAM. So in order to deploy to AWS, we had to make sure that we had a good understanding of which roles would avail us of being able to actually create those step functions and Lambda first. And that was the first challenge there that John mentioned a little bit, something that we didn't recognize, and this kind of goes back to the idea of not having a unified log, is that even though the SDK gives you a facility of being able to tell when your IAM role is created, which has to be created first to then create the other services, when you send a request to verify the existence of that IAM role, that does not mean that you can go ahead and create these other services, because as John was saying previously, there's really no way of peering into whether or not that IAM role has propagated the other services. So that's where we actually had to build some retry for our business logic, which was able to basically retry with a specific back-off rate that we kind of figured out through a little bit of trial and error to determine when the roles had propagated to the different services. So as far as dependencies, really those were the only 3 concerns. We knew we had to reconcile the first 2. There wasn't much clarity in working with IAM, so it was just a matter of trial and error to understand, which dependencies were required. And so then we basically took a composite of the policies and permissions that are applied on the roles we use and use that for the other workflows that we provided as templates. I'm not sure if that was exactly the type of answer for that question you were looking for. You can provide more specific questions to that question, a subsequent one, if that didn't answer. Really appreciate those thoughtful questions, though. Definitely appreciate everyone who's come out today. And don't be shy if there is anything regarding the presentation or the subject, serverless in general, that one's curious about. Again, it's somewhat of a new environment to be programming in. So there are many working developers who have many years of experience for whom some of the subjects are a bit unfamiliar as well. But don't be shy.
Yeah, and this is Zach. I just wanted to point out that Krunal had a comment saying, so lambdas and step functions work together. It's not that step functions replace lambdas, and that's right. Really kind of the goal of step functions is to help abstract out logic, orchestration logic that would otherwise you would have to choreograph into your lambdas, which is really just a single function that you're wanting to keep separated from other concerns. And that's where you want your business logic to live.
I have another question here regarding, the terminology versus orchestration versus choreography. And really it's a good question, because again, in a new field, there's a lot of conflation of terms. As we mentioned from the beginning, even FaaS and serverless are conflated, and that's kind of at the very top. We did rely on some resources where we saw the term orchestration really referring to the coordination of services in a workflow. One kind of paramount that comes to mind is in our write-up, which will be made available shortly, but really it mapped out the common patterns of orchestration, which really heavily rely on Lambda. But beyond that, there's actually some research papers. There's 2 or 3 academic papers in this area, and our write-up specifies that a little bit more as well, that actually dive into the fact that there's not really many best practices. And so the term that it uses is orchestration. And then it goes on to really clarify about 20 different patterns under those 5 different areas that we consider at the beginning: availability, communication, event management, so forth. And so we were actually relying not on I guess a broadly established best practices in the area, but some of the academic learnings that speak about the orchestration, using that term orchestration and not choreography.
Yeah, I'll just add real quick, another helpful resource for serverless in general is a podcast called Serverless Chats by Jeremy Daly, and he's an AWS serverless hero. And yeah, there was a lot of helpful information on there. And in one particular episode, he talked about orchestration versus choreography and kind of what's going on there.
It looks like we've got another question here in the Q&A. The question is, did you consider any cloud providers other than AWS? Why or why not? So actually, we did consider some other providers, but we actually ended up using AWS because the field that we were working in, orchestrating like serverless functions or functions as a service, AWS was by far the leader in that field with the AWS Lambda. So we decided to stick with AWS mainly for that reason.
And there are, other cloud providers have similar offerings as step functions. For instance, Microsoft's Azure has a service called Durable Functions, which is similar to step functions. And so, like John said, AWS is the prominent provider, and so we chose to go AWS. So we don't support any other cloud providers.
And actually, on top of that, another company made an internal tool. Netflix made one called Conductor that also is kind of a mirror of step functions. So even though we only consider step functions here, some of the same patterns are found in these other services. So if this discussion and what Maestro does makes sense, one can delve into some of these other services and find some other similar patterns, if not a similar framework, which likely does not exist.
Well, it seems that that's all of the questions. We just really appreciate everybody listening to our talk about Maestro. It's been a really fun past few months going through Capstone, and we really appreciate it.
Yeah, thanks again for your support, everybody.
Take care.